Hey class. So, as promised, I'm going to go over another two-step conversion problem. In class, we went over a problem that said with a given number of atoms, what's my mass in grams? So, we're going to do one in reverse now. This problem says how many atoms are in a 254.4 gram sample of gold. So now we're working with a given mass, and we need to get to atoms, or number of particles. If you remember that chart I showed you guys in class, that chart tells us exactly what we need to do depending on what we're given and where we need to go. So if we have mass, and we're given mass here with this 254.4 gram sample, we have mass, we need to get to number of, and the book calls it particles, but I'm going to call it atoms here. Particles means atoms or molecules. The conversion is the same for either one. We need to go from mass to number of particles, number of atoms. We don't have a direct conversion for that, but we can go from mass to moles. And from moles, we can go to number of atoms. So that's what I mean when I say two-step conversion problem. We've got to go from a given mass to the number of moles of that atom, and then the number of atoms itself. So given 254.4 grams, 254.4 grams of gold, the atomic symbol for gold is AU. The first thing I need to do is I need to multiply this by the correct conversion factor to get this value into moles. That's done by using our molar mass for gold. Our molar mass for gold is going to be read right from the periodic table. And I've got a periodic table in front of me. I'll put it on the screen. This is from the back of the textbook. And I can read gold right in the center right there. Has got a molar mass of 196.966. I'm going to call that 196.97. So gold has a molar mass of 196.97. So I'm going to multiply by 1 mole of gold is equal to 196.97 grams of gold. And we can put this value over 1. If it's not given to us in a fraction, we know it's in the numerator. We can add in a denominator of 1 whenever we want. It does not change the value. It just helps us see it in good fraction format. And we see that grams of gold cancels out with grams of gold right here. So we've got 254.4 with no units anymore times 1 mole of gold over 196.97 without any units. If we do the multiplication across, we're going to end up with 254.4 times 1 mole of AU. The 1 can go away. Multiplying something by 1 doesn't do anything, but I do have these units here still. So I'll keep my mole of gold up top over everything on the bottom multiplied together. 1 times 196.97. I don't need to bring the times 1 because multiplying something by 1 doesn't do anything. And we see we have 254.4 divided by 196.97. If I get out my calculator, I can do 254.4 divided by 196.97. I'm going to get 1.29. 1.29. That's what happens when I did 254.4 divided by 196.97. My only units left are moles of gold. So I've gone from mass to moles. All that's left for me to do is go from moles to number of atoms. If you check the chart from the book on page 230, you can see to go from moles to number of atoms, it'll tell you the exact conversion factor we need to use. I'll put my 1.29 moles down here. We need to multiply that by 6.02 times 10 to the 23 atoms over 1 mole. This is a conversion factor that chart gives me, but we also know moles has to be on the bottom because that's the unit that I have. The unit that I have has to be on bottom of my conversion factor so that when I multiply them out, I've got moles on top and moles on bottom. They can cancel out. And if I multiply across, I get 1.29 without any units times 6.02 times 10 to the 23 atoms. On bottom, I have 1 times 1 without any units. If something is just over 1, I can leave it out. I'm only working with the numerator right now, so I can just multiply straight across. 1.29 times 6.02 times 10 to the 23 atoms. So, multiplying with a exponent here, multiplying a number with scientific notation, I'm going to ignore, I'm sorry, I'm not on the screen right now. I just rewrote my problem out. So, I'm multiplying 1.29 times 6.02 times 10 to the 23. I'm going to ignore my scientific notation part, just work with my coefficients. 1.29 times 6.02. 1.29 times, 1.29 times 6.02 gets me 7.765. I'll round that up to 7.77. I've got 7.77. I ignored the 10 to the 23rd power, but I've got to bring it along for the ride, times 10 to the 23. And my unit is still atoms. So I'm going to do a quick check, make sure I'm in proper scientific notation. I am here because I've only got one non-zero digit to the left of my decimal. So times 10 to the 23 is the correct way to write it, scientific notation. I have my unit atoms here. And I'm good. 7.77 times 10 to the 23 atoms. That's how many atoms are in a sample of gold that has a mass of 254.4 grams. I'm going to recap everything real fast. I'll run it down. So I know from that chart on page 230 in the textbook, it'll also be on your lab manuals, that when I'm given a mass, and I'm looking for number of atoms or number of particles, I've got to go from mass to moles, and then from moles to atoms. It's a two-step problem, 2 steps that we're familiar with. We've done them both on their own before, now we're just combining our steps. I have my given unit. I pick the conversion factor from the book. That puts the unit that I want on top. I want to change it into moles first. And the unit that I have, grams, the unit that I was given, on bottom. The unit that I'm given goes on bottom because that allows me to cancel out these units. I've got a unit on top that I've also got on bottom, so I can cancel them both out. This just becomes 254.4 divided by 196.97. My only unit left is moles. Here I wrote in moles of gold. And I get an answer of 1.29 moles of gold. But I'm not done. That got me to moles. I still need to go from moles to number of atoms. So I've got my value of 1.29 moles. I multiply that by my conversion factor. That puts the unit that I have on bottom, which is moles, and the unit that I want on top, which is atoms. That happens because I want to cancel out moles on top. and moles on bottom becomes 1.29 without any units times 6.02 times 10 to the 23 atoms. Atoms is the only unit that makes it, that doesn't get canceled out. So if I multiply across the top, I get 1.29 times 6.02 times 10 to the 23 comes out to 7.77 times 10 to the 23 atoms. That's in proper scientific notation because I've got one non-zero digit to the left of my decimal. Times 10 to the 23 is correct, and that's my answer.